All right, we're starting Module 2, and this video is going to be the first topic in Module 2, and what we're talking about is exponents. Exponents, but we're going to actually talk about exponents and division. So we're going to look at problems like this, where you have exponent, something to a something power divided by something to a something power, or something like this, or something like this. How do you do division when you've got exponents involved? Now, before we talk about how to do that, I don't think I need to remind you how exponents work, because we've already talked about that, and I think you already know that 7 times 7 times 7 times 7 times 7 times 7 is 7 to the 6th power. But I am going to tell you a little rule here that will be very helpful for today's lesson, and that is, when in doubt, write it out. What I mean by that is, if you know that 7 to the 6th power equals 7 times 7 times 7 times 7 times 7 times 7, sometimes it helps to write all those 7s out. So here's an example. What if you were trying to figure out how to simplify x to the 6th power divided by x squared? We know that x to the 6th power is x, and we know x squared is x times x. And now that we have written it out, expanded it out, what we can notice here is that you can simplify this fraction by crossing out common factors. And so, with those x's getting scratched off, you now only have 4 x's left on the top, so that's x to the 4th, and it's just x to the 4th over 1, or just x to the 4th. Now what I want you to notice here is something peculiar. Notice where we started was x to the 6th over x squared, and the 6 and the 2 there ended up giving you a 4 as your final exponent. So the rule is, if you don't want to have to, when in doubt, write it out and scratch all those things out, you can just take the top exponent minus the bottom exponent. That would be like 6 minus 2 gives you 4. Ah, that's a nice shortcut. Of course, if you don't remember that shortcut, when in doubt, just write it out, and you should be able to get these problems correct no matter what. Okay, how about this? Z to the 14th power divided by z to the 7th power. It should be z to the 7th power according to this rule, because remember, you do the top exponent minus the bottom exponent, and 14 minus 7 is 7. Yay! Okay, what about a to the 30th divided by z to the 12th? We don't want to have to write 30 a's out, do we? Oh, but wait a second. You know what? This rule does not even work, because you can't do this with a's and z's, because a's and z's don't cancel each other out. So you can't simplify that one at all. So ignore that problem. But you can do this problem. What if I said simplify j to the 6th divided by j cubed? What would that be? J to the... You decide. Okay, so we're doing exponents and division. But what happens when the top number is smaller than the bottom number? You know you're supposed to subtract. We're supposed to do 2 minus 6 here, right? But 2 minus 6 is negative 4. Is it even possible to get a negative exponent? Are you allowed to have something to the negative 4th power? That's really weird. But maybe if we, when in doubt, write it out on this problem, we can get to the bottom of this weirdness. Remember, it's x squared over x to the 6th. And that came out to x to the negative 4th. But let's write it all out. X times x on top. There's 6 x's on the bottom. And if we match up those x's and scratch them out and match and scratch, now what you see is there's 4 x's, but the 4 x's aren't in the numerator. They're not on the top. They're in the denominator, aren't they? So it would be like there's x to the 4th on the bottom, and we'd have to put a 1 on the top as a placeholder. So what you might notice here is what came out to x to the negative 4 power also could come out to 1 over x to the 4th power. And that tells us that whenever you have a negative exponent, It means that that power is in the denominator. So you can have negative exponents. It just means that instead of squaring something, you're going to put it in the denominator and then square it. For instance, 8 to the negative 2 means you're still going to square the 8. You're still going to get 64, but it's not going to be 64. It's going to be 1/64. And 10 to the negative 3 means you're still going to do 10 times 10 times 10, but it's going to be 1/10 times 10 times 10. Negative exponents mean you do that power to that number, but then you stick it in the denominator, and then what do you put on the top? You put a 1 on the top. One little quick warning. Do negative exponents mean that your answer comes out negative? Nope. It just means that you do that power, but you do it in the denominator. So, what would you get if you had 7 to the negative 2 power? Try it. See what you come up with. And we'll talk about that a little bit more in class. All right. What happens in a problem like this? X to the 12th divided by x to the 12th. You know what the rule is. You know that you're supposed to do the top exponent minus the bottom exponent. You know that 12 minus 12 is 0. Now we have x to the 0 power. Are you allowed to have 0 powers? Well, 12 minus 12 is 0, right? Wait a second. Isn't x to the 12th divided by itself just 1? Isn't anything divided by itself equal to 1? How many times does x to the 12th go into x to the 12th? Once, right? So, the rule is that anything to the 0 power always equals 1. And you might remember this explanation about the exponents subtracting, and you might not, but all you need to remember is anything to the 0 power always equals 1. So 8 to the 0 power is 1. 11 to the 0 power is 1. 2.3 to the 0 power is 1. Anything to the 0 power equals 1. Even big numbers. And even 1 to the 0 power is 1. Anything to the 0 power always equals 1. So here's your third practice problem. What is 45,378 to the 0 power? You got it. We're done. Hope you enjoyed this lesson. We're going to talk some more about exponents mañana. Adios.